In Lesson 5.5, we're going to talk about what a y-intercept is. So you should recognize this graph from one that we talked about before. It is the plant club contest, and it shows the results of a plant growing contest among 3 friends at a local plant club. This time, the person with the tallest plant after 6 weeks is the winner of the contest. So, who won the contest, and do you think the contest was fair? And you are supposed to explain why you think that. So I will tell you who won the contest, but you have to come up with your opinion on it, if you think it was fair, and why. So since the person with the tallest plant after 6 weeks wins, you would look at this point here, that's the tallest one. So that means that friend 2 won. Now pause the video and write down your opinion on if you think the contest was fair. Hopefully you did what the video told you to and pause the video to answer that. And also, hopefully you realized that because the plants started at different heights here, you probably decided it wasn't fair. So we're talking about the y-intercept. That is where the graphs hit or cross the y-axis. So up in friend 2, this red one, the y-intercept was 6, which means the plant started at 6 inches tall. Friend 1, who had the plant that died, his or her plant started at 4 inches tall. And then friend 3, his plant started at 2 inches tall. So the y-intercept of the graph is the y value at which the graph crosses the y-axis. So we can see here that the y-intercept is 0, here the y-intercept is 4, and here the y-intercept is -3. Let's go through an example. We are supposed to graph the equation y equals x plus 3. So to do this, we're going to make a table. And our table is going to have 3 columns. The first column is x. The second column is going to be x plus 3, and I got that from here, x plus 3. And then the third column is going to be y. And then over here I'm going to write ordered pair. So I guess you could consider it to have 4, let's go ahead and make it 4 columns. Okay, so with the x, I can choose any x value I want to. It doesn't matter which one I choose. So I'm going to choose -3. So that means x plus 3 would be -3 plus 3. And that equals 0. So the y value is 0. And my ordered pair is -3, 0. I'm going to choose -2 for x. So it's -2 plus 3. -2 plus 3 equals 1. So the ordered pair, remember ordered pairs are x comma y, that's where I'm getting that. So my x value was -2 and my y value was 1. My next one, I'm going to do -1. So I'm going to figure out what -1 plus 3 is. That equals 2. So my x coordinate was -1 and my y coordinate was 2. I'm going to keep going. 0. So if I plug 0 in for x, I would get 3 for my y. So the point is 0, 3. Again, I'm going to keep going here. If I plug in a 1, I get 1 plus 3, which equals 4. So that would be the point 1, 4. All right, so now it's time to graph all of those ordered pairs. Now remember that the x value goes along the x-axis and the y value goes along the y-axis. So the point -3, 0 means I go -3 on my x value and 0 on my y value, so it's right there. So -3, 0 is on my graph. If I plot the point -2, 1, I'm going to go -2 on my x value, 1 on my y value, so it's right there. So I'm going to put the point right there. -1, 2, I'm going to go -1 on my x, 2 on my y, so my point is right there. Next I have 0, 3, so I'm going to go 0 on my x, so I don't go left or right, and I go 3 on my y value, so it's right there. And last I have the point 1, 4, so I'm going to go 1 on my x value, on my x-axis, and 4 on my y value, so my point is going to be right there. So it says to graph the equation, so those are only some of the points on my in my equation that work. To show all of them, I connect all the dots, so it would go on forever. Now it's best if you use a straight edge, and I don't have a straight edge on this software, so I'm going to have to draw it freehand. But that is what the graph of the equation y equals x plus 3 is. So now I'd like to make an observation. I want to see on the graph where the y-intercept is. So again, the y-intercept is where it hits the y-axis. And I can see it's my yellow point here where it hits my y-axis. So my y-intercept is 3. And so let's go ahead and write that down. The y-intercept is 3, and that's the point 0, 3. All right, let's take a look at another example. The equation y equals x plus 6 is given to us, and we're asked to graph it. So we're going to make our table again. So we have x, then we have x plus 6, then we have our y value, and then we have our ordered pair. So we're going to fill out the table. Again, I choose different values of x. It doesn't matter which value I choose. So let's start with -3 again. So I'm going to do -3 plus 6. -3 plus 6 is 3. So the ordered pair is -3, 3. So I'm going to go ahead and plot that point. So I'm going to go -3 on the x value, 3 on the y value, so I would get a point right there. Let's go ahead and plot that point right now. Next I'm going to plug in -2, so I'm going to do -2 plus 6. That equals 4. So my point is -2, 4. So let's go ahead and plot that one. -2 on the x value, 4 on the y value, so it's right there. Go ahead and plot that. Let's do -1. -1 plus 6 is 5. So -1, 5 is on my graph. So I'm going to plot -1 on the x, 5 on the y. So it's right there. Go ahead and plot that point. Next, I'm going to have 0. So 0 plus 6 is 0. Is 6. So it's 0, 6 on my graph. So I don't go right or left. I just go up to 6 and plot my point. And then let's do 1. So 1 plus 6 is 7. So the point 1, 7 is on my graph. So I'm going to go to the right 1, and I'm going to go up to 7. So that's the point right there. That's probably good enough for my graph. I'm going to connect the dots to show all these points on this black line would work. And again, it would be best if you used a straight edge. I do not have one on this software. Now let's talk about what the y-intercept is. The y-intercept is right here. It's where it crosses the y-axis. Remember, the y-axis goes up and down. So it's that red point there, and the red point had the y value of 6. So the point 0, 6 is your y-axis or y-intercept. Let's go ahead and write that y-intercept is 6. All right, now it's time to make some more observations. So let's come down here to example 2. We are writing the y-intercept for each problem. So when we're given a graph, all we have to do is look at the y-axis and see where the line hits it. So it hits it at -2. That makes it really easy. My y-intercept is -2. Same thing on the next one. The y-intercept is where it hits the y-axis. So that's at 2 on this problem. Now we're going to go back and look at our previous examples to see if we can identify the y-intercept from an equation. So if we take a look back here, the y-intercept was 6, and look at the equation, y equals x plus 6. If we take a look at the previous example, the y-intercept was 3, and the equation is y equals x plus 3. So you should notice that plus 3 is the y-intercept here, and the plus 6 is the y-intercept here. Now, why I'm saying the plus sign is important. If we come down here, it would be, if we rewrote this problem, y equals 4x minus 3, I could write it as y equals 4x plus -3. Remember, minus signs are keep, add, opposite. So we keep the 4x, we add instead of subtract, and we take the opposite of 3, -3. Keep, add, opposite is what subtraction is. So the y-intercept is -3. In problem D, we have y equals -4x plus 3, so my y-intercept is 3 plus 3, 3. So, in this equation here, y equals -5x minus 1, I'm going to write that as y equals -5x plus -1, keep, add, opposite is what I'm doing. Keep -5x, add instead of subtract. The opposite of 1 is -1. So keep, add, opposite. And the y-intercept is -1. All right, and then this last one, your friend claims that every line will cross the y-axis and therefore will have a y-intercept. And it asks us to provide a counterexample. A counterexample is an example that shows that this is not a true statement. So I am trying to tell you that this statement, every line will cross the y-axis and therefore has a y-intercept. I'm telling you that's false, but you have to give me an example that shows it's false. So if I draw a set of axes, you have to come up with a line on that set of axes that will never cross the y-axis. There are lots of different examples of them, but they all have something in common. This line here will never cross the y-axis. This line here will never cross the y-axis. This line here will never cross the y-axis. So those are 3 counterexamples to your friend's statement, and all 3 of them have in common that they are vertical lines. So I'm going to write over here, any vertical line is a counterexample. Sorry, any vertical line is a counterexample. And that summarizes what it looks like when it doesn't cross the y-axis.